What a time to be alive. Look at this thing. Yes, a drivable suitcase. That's right. Forwards and backwards apparently. And then you can use it as a carry-on when you're going on your travels. A very heavy thing. Look at the size of the front wheel. Anyway, it's not working. This was given to me to look at by my friend Mike, also a viewer of the channel. It was bought in Dubai. They're not cheap. Just check now on Amazon. They're still £450+, and in some places they're retailing for £500. So it was working absolutely fine, but then he dropped the battery. The battery's got a crack on it, and now the battery's not charging up. Apparently the battery still worked when there was charge in it, but he can't charge it up. He looked into getting a new battery and it's $300, so very pricey for a battery. So it's well worth fixing if it can be fixed. And this apparently is where you put your feet. So you sit on here, you steer it here, and you put your feet here, and then you can whiz around the airports. Right, here it is, unzipped. This is where you keep your battery and stuff, and you've got all your storage in here. So to get into here, we lift this up. Obviously you can wheel it as well. And this is the battery here. And if we put the battery in, and turn it on, there's nothing happening. And also, if we hit the button there for the battery, there's no signs of life. Looks like we got some USB ports here, like that. And look here, it's outputting this charger 42 volts DC, 42 volts. I think that's the highest voltage I've ever seen on one of the power supplies like that. So yeah, this is the battery. And if you have a look, there is a crack. Where's the crack now? Seen a crack yesterday when he gave it to me. Oh yeah, here. It's going across here and it's going down the side here. So it is cracked along there. So let's see if we can get this working. It outputs 5 volts and 30. Oh, it's got 2 outputs. Oh, 5 volts here for the USB and then 37 volts here for the actual suitcase itself. So really, that there is kind of irrelevant. That's just in case you want to charge something like this, just using it like a power bank, because it's going to be 37 volts here, and then you're going to be able to use the 5 volt sockets here. So it must be knocking it down. There must be a little circuit board hidden away in here somewhere to knock the voltage down to that, because that doesn't pass through from there. I think it's going to be quite interesting. Let's plug this in on the blue mat, see if we're getting an output here, and let's see if we're getting anything on the barrel jack here. So first of all, let's make sure that this is still working. It's center pin positive. So let's see what voltage we got in here. There you go, 42 volts. So looks like that's still working fine. Now, am I going to be able to get the probes in here without shorting out? I just want to see if there's anything in it at all. Yeah, 1.9 volts. 1.9 volts. Right, okay. That's very, very, very low though, isn't it? Considering that's 37 volts it's supposed to be outputting. There's tiny little screws in here, tiny little Phillips it looks like, in the corners. Let's undo them. Now I said at the beginning of the video, obviously take these videos purely for entertainment. I'm not an expert whatsoever on anything. I'm definitely not an expert on lithium power banks like this one here. So what you see in this video might not be the safest way to do things, the correct way. But I will give it a real good go. Right, there are those screws out there. Is it going to come apart now? Yes, it is. Well, that is lovely. That is lovely how it's come apart like that. Right, so that's going off to the little test thing up here. What are these? So these are the 18650s. So like, you know, like vape batteries. So be very careful. It was dropped here. This all looks fine though. I wonder. I mean, it must be related to the drop. Must be something on here which has gone. But what has gone? Can I see any crack on the board anywhere? No. Yeah, you can see it's cracked there. But it's not really bad, you know? So we've got that corner. Let me see what's in these cells. If I actually just go on the cells themselves, let's see if they've discharged themselves. So they're all really, really low. I wonder now, do you know what? I'm going to plug it in. I wonder if maybe Mike didn't leave it plugged in long enough to register a charge. Let's plug it in and see what's happening now when it's, when it's open. Because maybe it needs to be kind of plugged in for like half an hour or something before it will actually recognise a charge. Is there any lights coming on anyway? No, I mean surely it should start charging straight away there. Barrel jack's not broken. I don't think I'm going to be able to fix this because I can't see what's wrong with it. So first of all, I just want to check the barrel jack. It doesn't look broken at all, but I want to see if we've got 42 volts going into the board. So I undo the 4 little screws in the corner of this board, have to undo a couple of connectors, and then that will allow me to get underneath the barrel jack to test where it goes through the holes in the board and see with my multimeter what voltage we have. Right, so plugging it in now. Now let's see what we have. There we go, it's those two. 42 volts, so we have got 42 volts going into it. So this proves that the barrel jack is okay because we have got 42 volts going into the board. What we now want to check is the voltage going into the batteries themselves, because we have 10 batteries here in series and each battery is 3.7 volts. So in total that will be 37 volts. But remember, when a lithium cell is charged, it might be measuring 4.2-ish volts. So we could be seeing 42 volts if this was charged. But what charge have we got actually going into the batteries? So I need to check that out next. Right, let's see now if we have voltage on here. So where am I going to go between? I need to go underneath again, don't I? Oh, well, I can go here, can't I? Yeah, so look, we've got 42 volts going down that wire onto here. Well, if you look at my meter there, it's climbing, isn't it? That says to me those batteries are charging. I think they're charging, you know. Let's see what's happening this side. And again, look, it's climbing. I'm wondering if this was just left plugged in for a long, long time, would it come to life? It's just strange how we've got no indication on the battery thing at all, but maybe because it's so ridiculously low. I'm just, why did the battery pack let it get itself that low? Surely when the motor was kind of, wearing down, it would have just, it would have cut itself off. I would have thought, because these batteries are now kind of gone below the safe level, aren't they? From what I can see. So the strange thing here is that the BMS, the battery management system, hasn't cut itself off to make the product safe. It's not the case that the cells are registering 3.5 volts and the actual output for the power bank is 0. The output for the power bank is what the cells are measuring. So the cells are each measuring like 0.2 each, and there's 10 of them. So that's going to be roughly 2 volts. But why did it get that low? Because now these lithium cells, even if you can get a charge back into them, they would never be safe to use, especially on an airline. I mean, it's the worst place to carry them, isn't it? Because if it's a fire, then in a house you've got a chance to get out. What are you going to do on a plane? So unfortunately, even if this pack can be revived, it can never be put back into service again. Right, I don't think I'm going to do anything just yet. Let's put the screws back in here. I'm just going to leave it plugged in for ages and see if it then comes to life. See, I don't understand how the item works. Maybe it beeps at you when the battery's getting low. Maybe it was, maybe the switch was accidentally left on, and then just the fact that you know, if it was put in a cupboard or an attic, a loft somewhere, basement, then if that LED was glowing, maybe the LED would drain these down to next to nothing. You know, maybe there's some sort of cutout so on the motor side of things to say that, you know, like, no, don't let it go below a certain amount. But then maybe if you just left the on switch on permanently by accident, maybe that's enough to get the batteries completely dead. Who knows? Now, while we're waiting for that battery to charge up, we'll give a shout out to the sponsor of this video, PCBWay! So, if you're interested in inventing your own unusual products like this, then you might need to get yourself some circuit boards made up. So once you've designed them, you can head on over to PCBWay and get them to print them out for you. PCBWay have over a decade experience in the PCB industry. They have state-of-the-art manufacturing facilities and they use the latest technology to produce high-quality PCBs that meet your specification. At PCBWay, they have a range of services including PCB prototyping, PCB assembly, flexible PCBs, high-density PCBs, CNC machining and 3D printing. Now, if your project is going to be using components that produce a lot of heat, you could think about using aluminium PCBs because it will allow for better heat dissipation. It will transfer heat away from those components. And guess what? PCBWay do aluminium PCBs as well. So now let's get back to the battery pack and see if it's got any more charge in it. A massive thank you to PCBWay for sponsoring the My Mate Vince channel. Right, it's been about half an hour now, so it hasn't been long. But look, there really isn't anything happening here. I'm sure it should be charging a lot quicker than this. It just seems to be ridiculously slow. 2.6 volts. It's got to go all the way up to 37. Well, more when it's fully charged. It'd be about 40, 42 or 43. So look, there's 10 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it's supposed to be 37 volts on the output. And each cell here is 3.7 volts because it's a little lithium pack, and it very nicely says here 3.7 volts, 3.7 volts. Do you know what I think? I thought this went at the top here, but it doesn't. Look at where the USB and the barrel jack is, it's down the bottom here. Look where the damage is, it's here. So you see this weird thing going on in the battery? I think maybe a couple of cells have failed because of the impact damage. So if you have a look, I think maybe this one's failed, and can you see this is dented here? So maybe it is charging, but it's ridiculously low because, or maybe this has some sort of like internal short and it's drained. Could it have then drained the other cells if they're all in, well, mind you, they're in series with each other, aren't they? They're not in parallel. Do you know what I'm thinking of doing? I don't think I'm going to leave this because we should have, you know, something has discharged it completely. And there should be something flashing here. It should be doing something. I think you shouldn't do this on lithium cells, but I'm going to unsolder these three here. And I think we're going to let's take them out. Let's take out some of the cells basically. And let's see if we might be able to tell when they're out of circuit. Maybe one will have, you know, you never know. Maybe some of them will have a bit of voltage in them and maybe one won't. And that will suggest then that that one has shorted. I mean, it'd be unlikely that two's gone. But look, there's definitely damage here and there's damage here. And that's exactly where the damage is here. The reason you shouldn't unsolder them is because obviously heat near a lithium cell can be very, very dangerous. Good thing about these are, it looks like they're completely discharged. So they're going to be less dangerous in a discharged state than a charged state, but you still shouldn't put heat near them. So whilst I'm risking life and limb for the purpose of entertainment, how good am I? Selfless I am. Let's give a shout out to the My Mate Vince Massive. This month the members are KipDigital.com, Kip Hakes and Max Rokatansky. Having Fun Repairs, Chris Seal, Felipe at MrKeebs.com, DJ VG, Pixie, Robert from Timsy's Auto Air, Daniel Watson, Zeeks C, Anthony Dean, Bazza2, Ross Melanson, Ellis Garbett, Gaspar Heller, Richard Bergland and Jacob Coplin. Thank you very much to each and every one of you. Right, so we now have the board free, so hopefully now I won't cause any damage to anything on there. See, that looks fine, it's just the outer little covering that's gone. You know, it's all metal inside there, so I don't think that's caused the problem. I wonder, should I use my bench power supply and actually kickstart them, get a little bit of voltage in each of them, and then that might show me which is the faulty cell, because maybe one of them isn't going to take. I'm just going to see now the voltage difference between them, because that might give me a clue. See, these are all 0.2. Apart from that one, but look at this one here. This one's much lower. That's different than all the others. All the others are nearly 0.2. Or nearly 0.3. I know there's very little difference in it, but again, yeah, so that one looks different. Interesting. So every one of them is 0.2 apart from one which is nearly 0.2, but this one down here isn't even 0.1. Would that indicate that maybe this cell is faulty down here, not where it took the impact, but this one, well, unless this took the initial bash and then it might have bounced or got stepped on or something. I'm going to unsolder this one from the board here. Right, and you can see that they've been spot welded to each other, so I am going to have to actually just prise that off. I want to take this cell out, you see. Right, that's extremely destructive, but I managed to get it out. Right, let's see now if we've got anything in this one. Yeah, so it is measuring very, very low. What I'm not sure about, if one cell, if it's in series and one cell had failed, then I suppose it wouldn't charge properly, would it? It's just that there is still a voltage there. It's not like a direct short, is it? But it is lower than all the others. It's amazing how they're all so discharged. I actually think in this instance, especially the fact that it's going on an airline, I think Mike does need to just buy a new battery pack. But I am going to just mess around with it just for the purpose of the video. I wouldn't recommend this to be used because all these batteries, every one of them have gone super, super low. I mean, we're talking, it'd be different if it was like 3 volts, but we're looking at things that are, you know, 0.2 of a volt. They've been completely drained. Right, I'm going to get my bench power supply and I'm going to try pushing in a little bit of voltage into this on very low current and so very low amps. And let's see if we can get any life back into this particular battery here. Right, so it's at 2 volts at 200 milliamps. And we know that this is the positive here. Let's just double check that. So if we put the leads this way round, we'll get a positive reading. And if we put the leads this way round, it will be a negative reading. Yep, so we know that this here is the positive. Let's see what happens when I put it on here. Right, so it's drawing, it's 1 volt, it's gone straight to constant current, so it is drawing the 200 milliamps. but the voltage is climbing. 1.44, 1.5, 1.6, 1.7. So it looks like it's taken a charge. Let's just see now. Has that grown there? Yes, it has. Okay. So it looks like the lowest cell in the battery pack can still take a charge, and considering I only had the leads on there for a minute or so, it did go to over 1 volt, and although it's dropping rapidly, it's still staying a little bit. It hasn't gone straight back to 0.05 of a volt or whatever it started on. So I'm thinking that maybe the batteries here are okay. So what I'm going to do is I'm going to use the spot welder that I got sent over from Timsey Auto Air, and I'm going to spot weld this battery back in. The reason you spot weld it rather than solder it is because the heat is more localized. Soldering iron will heat up quite an area before the solder melts, but with the spot welder you're only heating up a very small bit, hence the reason why these lithium cells are all spot welded in the first place. So I'm going to put this cell back in the battery pack, and I'm actually going to charge up this battery pack with my bench power supply. So I'm not going to do it via the circuit board that comes with the battery pack. I'm going to do it straight from my bench power supply to try to get some serious voltage into these cells, but in a safe way. So for example, when they're all in series together, I might start with maybe 10 volts at 0.2 of an amp, so 200 milliamps, and then slowly build it up and up and up to get the voltage in there safely. So that's what I'm doing now. I'm just doing the spot welding. Let's see a little bit of that. Ah, so relaxing, therapeutic. The sound the machine makes, a sudden release of energy. Spot welding is something special. I need more of it in my life. Anyway, I am now going to get my bench power supply and let's get some voltage into this battery pack, and then we'll take it from there. Right, what I'm doing is I just soldered a little wire onto the negative there. I've still got this one disconnected from the board, so we are just purely charging the batteries. The positive here isn't going through the board because these two things are disconnecting each of these side rails that the batteries are connected to. And now I'm putting in the voltage as a whole. So what I'm doing is I've got it set to 20 volts, still at, I think it was 0.22 of an amp. And you can see now that we've gone into constant voltage mode, because it's reached voltage, but it's going in at a very low amperage there. So I'll leave that for a while, and then what I'll do is I'll up the voltage more, because remember, this battery charger here is pumping out 42 volts, and right now we've only got 20 volts going into it. And bit by bit I'm just going across with my meter just to make sure that that there's voltage going into the cells, and also I'm feeling them to make sure it's not getting overly hot. So yeah. Here we go. Right, so I've had it plugged in now for about 45 minutes. None of the batteries are getting warm, but they are definitely accepting voltage when we charge them directly like that. And if you have a look here, I'll put my bench power supply to the maximum voltage, but not the amps. This will do 10 amps. I'm only at 0.2 of 1 amp, so 200 milliamps. But look, I've gone to the maximum voltage, which is 30 volts, but it's coming up as 31 volts. And at long last, this is actually taking voltage now. So what I might do is, I'm tempted to put it back together and see if the this will take over, because this is going to charge at much higher amps. You can see here output 42 volts at 1.5 amps, but I just don't quite know if this is ready for it yet, because although we've got charge in the batteries now, I have been charging at a very low amp. So I think what I'll do is, I think it'd probably be best for me to keep it at a lower voltage of 30 volts, 31, maybe 32, and I think it's probably best for me to increase the amps. So I might up it to, in fact let's do this now while we're here, let's up it to 0.5 of an amp. Is it going to allow me to get, no it's not. Okay, 1 second now, let me unplug this for a moment. Let's short them together and see what amps we're at. See, I feel a bit unsafe doing that now because there's 30 volts in there. Okay, let's just see. Right, short together now. There we go, let's leave it at that rather than messing with it. So we're nearly at 0.6 of an amp. So plug this back in. and I'm going to let it do its thing. Thing is, it doesn't matter what amps I'm going to put it at now. It's going to, it's reached a maximum voltage, hasn't it? Yeah. I'll leave it like that for a while because it's still putting a bit more amps than it did before. And then what I'll do is I'll solder the wire back on and we'll let this take over, and we'll see then if there's more, you know, see then if we have any signs of life coming from it. Well, I'm going to solder it back on and see what's happening. So if I go across these wires now, so this is measuring purely the pack of 10 batteries. There you go, we've got 31 volts. So it means that each cell should be about 3.1. 3.1. 3.1. 3.2. The dodgy cell. 2.9. Interesting. Right, let's solder it back on. Let's plug this in and see if anything lights up. Right, here goes. Excellent, we've got a light. Right, okay. We've got a light. Let's plug it in to the original charger. So I'm using the actual Airwheel charger now. Is anything going to happen? Should anything happen? I mean, should these be lighting up? I don't know. I think I'm going to have to get the instructions for this. Let's see if we have anything growing here. Because we know where to measure now, don't we? I'm just going to go across here and here and measure the whole power bank itself. So I'm on here and here. Well, no, that's just going to measure, hold on. Yeah, that's going to measure the power bank, isn't it? Yeah. And it's growing. Right, let me unplug that and see if it goes down. Yeah, so we're 32.9. And then when we plug it in, it grows. I'm going to watch a couple of reviews because I would have thought that when you had it plugged in, there should be some kind of indication that it's charging. I would have thought that this would be flashing red. And then when it's charged, it goes to green. Or is the idea you just keep pressing this so you know where you are? I suppose we'll know once it gets to like 3.7, once it gets to 37 volts here, really then it shouldn't be on that one anymore. It should then start to go onto here, shouldn't it? Onto the scale. It's climbing much quicker now than earlier on in the video. So I think what happened was because it was so low earlier on, it was refusing to charge the cells, and quite rightly so, because these shouldn't be charged when they discharge themselves. It's a safety feature of them. But now that's really ramping up. As in, I think in an hour or so, you can see at that speed that we would be up to 40 volts. Oh, yes, we've got a green light now. Excellent. Fantastic. Oh, I like that. We're up to 25%. But we still don't know what drained it in the first place. And I'm still iffy about this cell down here with my little finger touching. Right, okay, well, I'm going to leave that charging. I'm going to obviously monitor the heat on the cells. And if any one of them feels particularly hot, then I'll unplug it. Also, 1 second, let's see now if I unplug that. So that's there. Have I got anything on here? No, so I still haven't got anything on here. But it looks like it wants to light up for a second. Look, can you see there? Okay. Again, maybe because it's too low. I wonder, do we have any voltage here on that? Yes, we do. There you go, 5.1. We've got 5.1 volts, so why is it not actually allowing it to plug in? Oh, here we go. Result! Do you reckon I'd somehow reset it? By plugging it in a few times? Yeah, look at that. Oh, okay, didn't do it that time. I think we just need to give this a good charge for a while, and I think it will all spring into life. I'm well happy with that. Apologies, I've come back in again just a few minutes later. Feeling the batteries, I can feel out of all of them that the warmest one is the one that I'm worried about. Yeah? It's not hot, but it's warm. Right, so there's a few things going on here now. So basically, the cell that I was worried about, because it was measuring much lower than all the other cells at the beginning of the video, is now the warmest out of them. Not hot, but warm. So it's acting different than the others. I think I'm going to swap it out for another cell, just to eliminate it. And, you know, a new cell. Also, this USB is not working. We've got voltage in these cells now, and the USB is still not working. So remember, something drained this board down to nothing. I'm thinking at this time of the video it could be the cell, but also the USB port's not working either. So yeah, let's get the cell swapped out. I just want to show you how I know what cell to swap it out with, and then I'll fast forward through the installation of that, and then we'll see whether everything's behaving differently. Maybe then the USB port will come to life. If you have a look at the batteries here, I have got some of these 18650s, but unhelpfully it just says 3.7 volts, 9.25 watt hours. It doesn't tell me what milliamps that is, but luckily we can work that out. So can you see here? It says 3.7 volts, 9.25, 3.7, 9.25, yeah? But look, check this one out here. This one, again, it's the same, you know, same size and everything, yeah? But if you have a look, it's 3.7 volts, and then it just says 2,500 milliamp hours. But that doesn't tell me what it is in watt hours. But look at this. What's the odds of it being exactly the same? So to get to it, to watt hours, we have to do the milliamp hours, which is 2,500. We have to times that by the voltage. Let me zoom out a bit. So we're going to times that by 3.7, and that equals 9,250. We divide that by 1,000, and that equals 9.25 watt hours. So this is the same as this, it's just a different color. So go through that again, 2,500 times 3.7 equals divided by 1,000. So what I'm going to do is, because I'm not happy with this cell, and it could be because this is where it got dropped, you know, on this it could have taken the impact here. I'm going to rip this apart again, which is going to be slightly more dangerous now because I've got charge in it, and I'm going to replace it with this one here. So I'll take out the suspect cell that I spot welded back in earlier, and it's a lot easier to take out because my spot welds are not as strong as the manufactured ones. But anyway, I put the replacement cell in, and guess what? It makes no difference whatsoever. The USB port is still not working. It will sometimes charge up something for a few seconds, and then it will just shut itself down. Now, I text Mike to get a bit more info. Basically, I was hoping that maybe the battery power bank was left in the suitcase, and then maybe the power button was left in, so the red LED was just lighting for like 2 months, which might have been enough to drain down the battery. No. He didn't put the battery in the suitcase up in the attic because he was worried because the battery had been dropped. So this battery was not near the suitcase. It just managed to discharge itself. So we now know this was put away working. So it was bought in Dubai and then it was dropped in Dubai. It was used in this country upon landing, and then it was put away working with the battery not in the suitcase. And then when they were going on another trip, he went to charge the battery and it never charged, which is when it's come to me with the cells completely depleted. So annoyingly, there's something on the circuit board that has depleted this battery. So yeah, if I'd asked the right questions at the beginning, then I suppose I would have had more to go on. But yeah, it means then that this isn't like a kind of human error fault. This battery power bank has discharged itself, and it shouldn't. A battery power bank like this shouldn't discharge itself because it will never charge back up again once it hits below the safe voltage of the cells. And 0.2 volts on each cell is well below the safe voltage of these cells. So yeah, the power bank has basically ruined itself. Whether that was caused by the drop or was it a manufacturing problem from the beginning, I don't know, because this would have only been charged briefly in Dubai. So now what we have to do is, changing the cell hasn't made any difference. We need to find out what it is on the circuit board that has caused these batteries to drain. Well, okay, so what I've done here is I want access to the board here, both sides. So I've still plugged in these bits here. I just use little jumper wires to extend this out over here. And I've been tracing back from the USB because we know the USB isn't working. Strangely, a couple of times I did have voltage on it, but then it would disappear. Now, I want to show you a chip. I have since blown up the chip, which I'll show you in a second. But basically, we have the positive pad off the USB on this one here. And it goes through the inductor and it goes along here. It goes through a diode, but it also continues on this side into this chip here. Let me zoom into the chip. So basically from here through the inductor along here, and can you see it goes into this part of the chip here? So this is like the output here. Now, I looked up what this chip is because I could see that it said on it 54160 across this bit here. And it is a 60 volt, 1.5 amp step down regulator with an integrated high side MOSFET. So basically it looks like you can put in roughly about 3 volts to 60 volts on this input pin here, this one here. And then I presume it's going to output here 5 volts for the USB. Now, I was getting, and still am getting, if I zoom out, if I go across this one here, I am getting 30 something volts feeding it. So look at this. If I use that as a ground, and if I go onto that side of the capacitor, which is also the side of the big capacitor here, you can see on that pin we do have 37 volts feeding it. So we've definitely got the voltage going into the chip. Now annoyingly, because the pins are so close, I was going across the pins, and basically what I did is I tapped between the 37 volts, and it was either that side or that side, but it burnt a nice big hole here. So now the chip has completely gone. Ridiculously, these are really expensive on eBay. There's only one seller selling them, and it's £15 plus £3 or £4 postage. So I don't want to do that because this isn't actually going to go back into service, is it? We just want to prove what's wrong with it. But I'm wondering now if that chip's failed, and that's the reason why we weren't getting the USB voltage here. So this is what I'm going to do. I'm going to use some hot air. I'm going to remove this chip, and then it will be interesting to see if over time it still discharges itself, because remember, this discharged itself to nothing. Those cells were 0.2 of a volt. So it discharged itself to absolutely nothing. So something on here had to be draining it. Let's take this chip off. I think that's the faulty chip. So we're just removing this little chip with hot air. The only reason I pinpointed this chip is because it's linked to the USB port, and I know the USB port is not working. So once we get the chip off the board, we can connect up the multimeter in series with the board, and we can see whether it's actually draining any current. And that will give us an idea then over time, if for example it looks like quite a high reading, we know then that over time this board would drain those batteries to nothing. I want to know if this is draining anything, because that's obviously what's happened. Something on the board has drained, and it's drained the batteries down to nothing. I think it's this chip, but I don't know. So rather than waiting for days on end, why don't I let my multimeter show me what it's draining? So what I did is I've unsoldered this red wire here, and now the batteries are disconnected from this board because I've unsoldered it here. It's still connected by the negative, but not the positive. If I was to put my meter in line with this from here to here, it's now connecting to my board through the meter. And all I have to do is move this from here to, I want to go on milliamps. Not amps, I want to go on milliamps to really show small amounts. If I go across here and here, you can see that we have got, remember this is 1 milliamp here, so it's 0.004 of a milliamp, and the battery is capable of 1980 milliamps. Yeah, and right now it's drawing 0.005 of a milliamp, not even 1 milliamp, and this is 1980. So that says to me that this board isn't draining anything. And just to show you it is working, watch this. When I do the LEDs here, the LEDs can only be powered from these batteries. There's nothing else connected to it. It will jump up because it's lighting the LEDs. Can you see there? 0.3, nearly 0.4 of a milliamp. and then it goes back to nothing again. So we know this is working. So I can't do the sums because I don't know how to, but if we were to go, so this is normally, what's this, normally about 0.005, so that's going to be 10 times would be there, 100 times is there, so 1,000 times would get you to 5 milliamps, and this is 1,980. So if this is on for 1,000 times the amount, we'll get to 5 milliamps, and this is 1,980. So that says to me in this current state, it would last for years before it would drain. But this is milliamp hours, and I don't quite get what's going on here. Is this right now drawing, I suppose if I was to keep it there, it's drawing nothing, isn't it? I mean, if I was to take it off, no, I mean, to be fair, that is 0. I think I'm correct though. I think I've proved it. I don't think we have to leave this for days on end because we can see it's not drawing anything. So right now, these batteries will not go flat again. See, I am tempted to buy a chip for £20 just to prove it, because you see, it might not necessarily be a chip. It might be something that the chip is passing through. It might be a capacitor that when it's dropped has become more like a resistor that's draining it down. So I think it's linked to the chip. I can't say with certainty it is the chip. It's whether I want to spend £20 or £18 on a chip when this thing still can't be used, because annoyingly the batteries were drained down to nothing, and it's a safety feature because it's on an aeroplane. It just can't be used again. But look at that, right now it's not drawing anything at all. What's interesting is when we plug this in, it also draws a little something. You see? It goes up a little bit, doesn't it? So it's still detecting the USB. Then it will drop down again. Okay, it's about 5 days later, I think it is, and it was eating away at me. I had to find out, was the chip responsible for the USB not working? So what I've done is I've gone out and bought one. It was, I say gone out, I didn't go anywhere. It got delivered to me. I think including postage it was nearly £20, which I know is silly because this can't be put back into service, so why am I spending money on it? Really, it's just for peace of mind to find out was the chip at fault or not, and also I think it will make a better finish to the video. So yeah, waste of money, yes, but still, at least we'll have more outcome to the video. I'm thinking now that maybe it's not going to make any difference, but we need to find out. The battery itself is currently flat purely because my son's enjoyed whizzing around the house on this. Apologies, Mike, but it has been on clean carpets and clean kitchen floor and stuff like that. So he's done it until the battery won't push it anymore now. It just goes for a few seconds and cuts out. So the item itself does stop the battery from going too flat because it keeps cutting out. But right now we're down to about 25 volts in this, but it doesn't appear to be dropping. It's been 25 volts for ages, and I stopped checking a couple of days ago because it was just always 25 volts. If you have a look here now, there you go, 25 volts still. Yeah, and it hasn't changed from that. So I presume eventually that will go off completely like it did before. So let's pop this chip in and see what it does. Right, we're free to solder. I'm going to do this bit under the microscope because it's really very, very small here. So I want to see what I'm doing. So I soldered the chip back in. For some reason I cannot find the footage on the microscope, but yeah, I have got the footage off doing the next part, which was basically reflowing all the components in that area around the chip and the USB port, just in case when it got dropped, if it caused one of these joints to fracture that I haven't seen, a quick reflow will fix that. Right, so it's about a week and a half later now, and I changed the chip out and reflowed all the components in this area here. And I have got a conclusion to the video, but it's still not perfect. This was never going to be perfect anyway because the battery cells were drained way too low to make it safe to charge again. So from the very beginning, this was basically faulty. It could never actually go back into service. But I just wanted to prove really what the fault was on the video. Now, when this chip wasn't in it, it wasn't charging. Now the chip's back in, it is charging. But for some reason, we can't get it to charge more than 50%. So right now, we're at about 25% or 50%. You can see that it holds on to the 25% longer than 50. But look, right now, green light here, plug it in here, it will go to red, and you will actually see that it does charge because you can see it climbing up here. So look at my meter. and it will go, and it's holding on to that charge, 37.22, it will be 2.3 in a second, then 2.4, and over the last week and a half I've been monitoring it, and it's not losing the charge. So it does appear to be keeping its charge now, which is good. But why will it not charge past 50%? That's really, really weird. So what will happen is I could leave this on for hours on end, and it will go to 38 here, roughly 38, and it won't go anymore. It's really, really strange. I've never got it to light up to 3 lights on the green thing down here. So there you go. But you can see right now it is charging, yeah? But I've never got it to go to 75 or 100%, only ever halfway. Now halfway will make it work for about 15 or 20 minutes on the actual suitcase. I'll show you that working now. It is actually a lot of fun. My son and daughter love it, and also I love how smooth it is. It feels, it's actually very addictive. It reminds me of a hoverboard when you put the little cart on it and you control it when you sit down with your hands rather than having to use your feet on it. If you've seen me trying to fix my hoverboard videos a few years ago, you would have seen them. So anyway, yeah, so this is 100% holding on to its charge. You can see there, nothing's plugged in. And now, look, check out the USB. So we have got this power bank here, and if I plug it into here, you will see that it will start charging here. Yeah. And if I get this one here, this power bank, you will also see that it will start charging. So it looks like maybe that chip was at fault. Even though I blew the chip by fumbling with my leads, it looks like maybe that chip was at fault, because look, it is charging now. So yeah, if we plug in the amp meter, you will see that it lights up. So let me get this back together, and then I want to show you it working on the suitcase. Okay, so we pop this in here, like so, and we can turn it on like that there. And these light up here, you probably can't see now, but they're actually glowing. There you go, on and off and on again. So it's a nice little advertising for them. You can see it better outside in the airports. If you wanted to use a USB ports here, you can do. So plug that into there and this one into here, and you will see they're both charging. Oops, there we go. And you can see the lights here and the lights there, so they're charging. Now let's unplug these. To make it work is really very nice. So you can put that down, lift this up here, and basically this one here will make it go forward very fast, and then this is a brake, so you go forward and brake, yeah, but it's not a sharp brake, it just slows it down. You can feel it when you're going fast, it brakes quite a bit, but then towards the end you just keep on rolling, but obviously you can put your feet on the ground. To reverse, you just hold this one down and then that way, and it will reverse. So this is forward, brake, and then hold down again to reverse, and it really is very, very fast. So I'll just take you for a quick spin inside, and then I'll show you it working outside. Now obviously I'm doing this one-handed, so brake, reverse, turn, and then whee, off, we're off, and brake. There, so it brakes to begin with, but then it just rolls after that. So nice tight turning circle as well. It feels so smooth, the pickup on it, and also it's speed sensitive. So look, you can go slow like this, and then fast. Brake. Obviously, you need a bigger area to fully experience the splendor of the Airwheel. Listen to how smooth it is. It's a bit, whoops, it's a bit top heavy, meaning that if you go around the corner a bit too fast, you have the tendency to fall over. But it's got a lovely turning circle on it. There you go. Look at that. Whee! You getting dizzy yet? Because I am. It doesn't work as well on carpet, but it does work, but it feels very sluggish on carpet, because I suppose there's a lot of resistance on the back wheels. Well, I suppose it depends on how thick the pile is on the carpet. Tight circle there, go on, get through. Right, let me show you a little bit outside footage. Right, now this is going to be a little bit more rough than inside the house. Let's see how it performs. I could do a bit of an obstacle course actually. Yeah, let's go down here. I'll have to reverse out of here, Could have hours of fun. Turn. And brake. Certainly so smooth. I think it's just a pickup from the oh, I didn't want to get over the crack there. It's just the electric pickup. I suppose it's similar to a car. It just feels nice, or like an electric go-kart, you know. It's just like the power's just there. Well, it is a lot better than expected. It is a lot of fun. Yeah, I like it. And just before we finish up the video, Mike said that I think he said he forgot the code on this, so I'm just going to show you how to easily pick this particular lock. Obviously this is not going to apply for all locks, but on this one it's made quite easy. And before I go, Mike hasn't given me the code for this, so what am I doing? Don't worry, these things are actually quite easy to get into if you've forgotten your code. So years ago I would have just put pressure on it and I would have kept turning it to see when it gives. But I think they are a little bit more advanced than that now, because I can't feel any difference. Usually you do this and you turn it one at a time and you feel it give a little bit, and then you can do the next one, but it's not doing that. But if you look really closely, they've made it nice and simple. There's a little cutout on each of these to the left hand side, and all you've got to do is get a torch, a flashlight, or your phone torch and shine it in here, and basically it's smooth all the way around, so it's like just a cylinder, but then there's a little notch. All you have to do is line all the notches up and then see if it works. If it doesn't work, go up or down one lot, all of them one lot, or down one lot, and then you'll find your code. So let's zoom in and see if we can do this. I promise you Mike hasn't given me the code for this. So now let's get it nicely angled so you can see. There you go. Can you see it's orange in here? And it's nice and smooth. Let's turn it around one. Still smooth. Turn it around one. Still smooth. Now, hold on. There you go. Can you see? Can you see it's different? So that's smooth. Now look. Can you see it's deeper now? Yeah. And if we go here, my finger's in the way. 1 second now. Let's see if I can angle it. There. So it changes. So it goes from smooth to an indentation. I'm not sure if that's coming up on camera. But basically, I need to do that to all of them, and then I'll find my code. Smooth. Oh, sorry, let me just take a note of this one because I just knocked it. So that's smooth now. Oh, you can really see it now. Right, so 5 is the first one. Now I must say on this one it's particularly easy because it's bright orange. Sometimes it's metal, so it's harder to see. Sometimes it's black plastic, so it's harder to see. There. 2 is the second one, so move that back to 5. So it's 5, 2. Last one. It's good, isn't it? Also, it might not be all moving it 1 along at the end. It could be 5 along, up or down. Sometimes I think it can be a combination of maybe the last 2 digits, 5 up, and you keep the first digit the same. So it might not necessarily be easy in all instances. There you go. 0. So it's 5, 2, 0. Right, let's zoom out. Right, is that going to work? No, it's not. So now let's go down 1 on each of them. Still not going to work. Down again on each of them. Still not working. Still not working. Still not working. There we go. 0, 7, 5. So that's it. That's how you find out the code on this. So there we have it. I enjoyed this a lot more than I thought it would. I thought it was just going to be like a novelty product, but I can actually see a use for it. And now I'm also thinking more about mobility scooters. I'm going to just do a little bit of research into them, because from memory, the ones that I've seen in the past have been very big and bulky. But let's say now, if you were just, you know, you were waiting a knee operation. Yeah, so my dad needed a knee operation. He was completely healthy. It's just he had bad arthritis in his knee, and it made it so he could barely walk like 20 meters. And even that was hobbling, but he had plenty of strength. So maybe something like this. Imagine now if this came up at the back and you could push it back to make it more into a seat, and if this came forward like that, then, you know, for people like that still have their balance, that are not overweight or anything, they've just got a part of their body that's not working properly, then something like this would be good to get your groceries in, because you go down to the shop in this, it only has to go walking speed, and then you can load up this with your groceries and then ride at home. So it's like a rideable shopping trolley. Surely there has to be a market for something like that. Maybe there already is, maybe the market's flooded with them. As I say, I've never looked into it, but still, it's good to see products like this because it gets your mind thinking about other uses. Now, when it comes to the faults, I swapped the cell over, but I don't think the cell was faulty. The cell that I've taken out is still holding its charge now. So all these cells are faulty because they were dropped below the safe level, but I don't think that they're the cause of the problem. I think it must be to do with that little chip that I blew up, but then I've swapped over. And we know that that's constantly being fed with the voltage from the battery. So maybe if that chip was always on, you know, the MOSFETs in that chip were on, they might be putting power through to different chips. And although it's not going to be draining much, maybe it's enough to drain it down over time to the low levels of 0.2 volts that you've seen at the beginning of the video. I'm not too sure really. The other thing which is weird is, why is it only charging to 50%? And as well as that, when you plug it into charge, the light on the charger goes from red to green, so the charger thinks that it's charged up. So is the charger also intelligent? Maybe the fault's with the charger. Not too sure. I haven't got another charger that can output that much voltage, unfortunately, so I'm not too sure about that one. You pop it down in the comments what you think. It's been very confusing for me. As well as that, the USB ports, it does, this one here on the actual thing, not these ones, but this one here does charge, but yet the power bank gets very hot when it is charging. But yet when you're charging it via the charger and when you're using it, the power bank doesn't get warm. So yeah, I'm not too sure whether these faults are from manufacturer or all to do with it being dropped. I suppose we will never know. But overall, the product was interesting and we got some kind of life out of it. So I suppose it's a partial success, but unfortunately from the very beginning, this was never ever going to be able to be fixed because of the nature of where it's used and the safety aspect. So a massive thanks to Mike for letting me work on this product. Apologies I couldn't get a successful outcome. If the rest of you enjoyed it, give it a big thumbs up and I will see you all very soon. Thank you so much for watching.
I was old, I was young, I was sitting in the sun, I was tired of the run, I was done. Life was great, life was hard, in a way an awful card. You can't win the losing hand. But the rain stopped falling and the line on the floor was crossed, and the pain I'd been feeling washed away to return another day. I was cold, I was bold, I had fragmented my soul into pieces